Hello class, this is Brannigan's Building Construction for the Fire Service, Chapter 14, Collapse. This chapter reviews precipitating factors and indicators that firefighters can use to predict collapse. It covers types of collapse, explains how to establish collapse zones, and reviews the collapse of the World Trade Center towers on September 11, 2001. The objectives we're going to cover in this class are as follows. We will explain the role of situational awareness in collapse, identify the indicators used to anticipate collapse, identify the various types of collapse, and apply a risk analysis to fireground safety. We will also identify the specific basic competencies all firefighters should have to perform at a structural collapse, and explain the essential elements of the collapse of the World Trade Center Twin Towers on September 11, 2001. Now we're going to start off with something a little bit morbid, and that is how firefighters die. Unfortunately, the number one killer of firefighters is heart attacks. That is the greatest killer today. The second greatest threat is smoke inhalation. The third is falls, and then building collapse. And all of these things combine to produce the greatest threat to kill in number. Now let's talk about situational awareness. The perception of the surroundings in terms of time and space, the understanding and comprehension of these observations, and the projected outcome of a change in these conditions. Firefighters, company officers, and the incident commanders all must be aware of what is happening. Now we're going to talk about communication. Communication is essential for situational awareness, and there are certain protocols for collapse warnings. Anticipating collapse. Firefighters must rely on training and experience, and firefighters must use indicators and known precipitators. There are some general visual indicators of collapse, for instance, cracks in walls, such as you see in the picture here, and leaning walls. Also, there are pitched or sagging floors. Another thing to look for are racked doorways. This is the presence of building stabilization and bracing features, as you see in the picture below. There are audible and physical indicators of collapse, moaning and groaning sounds, and cracking noises. Any type of movement or shifting of water on the floor. Also, smoke pushing through cracks in the wall, vibrations, and lack of water runoff from firefighting operations can all be indicators of collapse. Environmental precipitators of collapse include heavy snow or rain load on the roof and heavy wind collections. Also, earthquake and impact load. There are occupancy precipitators of collapse. For instance, overloading of floors and or roof, and concentrated loads, and also waterlogged goods. Existing structural instability precipitators of collapse can include structural compromises of load-bearing members during renovations and previous fire damage, as well as rotting or corrosion of structural members from water leaks or damage. Also, there can be compromised or broken structural elements, eccentrically loaded columns, and buildings under renovation, construction, and buildings being moved. Fire and explosion damage are precipitators of collapse, and sustained or moderate to heavy fire damage can also cause collapse. as well as explosion and loss of wood structural mass due to fire attack. Lightweight construction precipitators of collapse can be unprotected bare steel members subjected to fire, wooden I-beams and lightweight wood trusses subjected to fire, particularly when directly exposed to basement fire or when burning in a truss void. Now let's talk about risk analysis after fire fatalities. Questions are asked, and fatalities are often caused by antiquated macho attitude. Taxpayers are saddled with unnecessary expenses. Professional fire service analyze the relationship between risk incurred and benefits obtained. Are well informed about construction features of buildings that have been available for study for many years. There are different types of collapse. There's global or total collapse, which results in the complete failure of the building and the destruction of the World Trade Center, Twin Towers, and Building Number 7 are examples of global collapse. Progressive collapse is a collapse in which a relatively small area of structural damage results in a loss of localized load-bearing capability, initiating a chain reaction of subsequent failures resulting in a major structural failure, including global collapse. Secondary collapse is an additional collapse that occurs after the third collapse. It often occurs when loads shift after a primary collapse, causing additional portions of the structure to fail. It can happen during search and rescue operations. This is an example of a pancake collapse. This is a collapse of a building's floors and possibly a roof in a pancake stack fashion with each floor or roof lying flat on top of the one below. This is a lean-to floor collapse. This is a V-shaped floor collapse. This is a collapse in which the floor fails near its center, with the perimeter of the floor still partially supported by the walls. Two voids are created in this type of collapse. Then you have a cantilever floor collapse. This is a collapse in which one end of the floor is still supported while the other end is unsupported. Voids can be created in such situations. A frame floor collapse or a tent collapse, and a collapse in which one end of the collapsed floor is supported by an interior wall and two void spaces result. An inward-outward collapse is a collapse in which the exterior wall fails horizontally with the interior wall folding horizontally. A 90-degree wall collapse is a collapse in which an entire wall fails as one unit. A tilt wall failure, which can fall in or out, is an example of a 90-degree collapse. A 12 lean-over collapse is a collapse characterized by a wooden building that shifts at the upper levels, leaning into adjacent buildings, or totally collapsing sideways in the absence of adjacent buildings. It's limited to a wood frame structure, and there's also what's called a curtain-style collapse. This is often associated with brick veneer non-load bearing walls, but may also include other masonry walls. Let's talk about established collapse zones. Firefighters and fire apparatus must be kept out of collapse zones. They must stay far enough away from the structure so that any debris thrown during a collapse will not cause injury. Untrue. Staying back 1/3 the height of the building is safe. Firefighters must remain at least the full height of the wall away. Minimum collapse competencies for firefighters include NFPA Standard 1670, which is the standard on operations and training for technical search and rescue incidents, and identifies the minimum competencies. Higher competency levels require higher training. Now let's talk about the history of the World Trade Center. Two of the tallest and largest buildings ever built were the Trade Center in New York. They were exempt from local building and fire codes, and each story was 110 stories high. Each floor was 40,000 square feet in area, and each side of the building measured 210 feet in length. Major structural components of the towers included the exterior walls and a series of columns in the center core. Lightweight steel floor trusses formed a composite floor, and there was also what's known as a hat truss. The mechanism of collapse was studied by the National Institute of Standards and Technology, or NIST, and it used visual evidence of the exterior damage and computer modeling. The North Tower, Tower 1, included 7 factors that caused the collapse: structural damage from the planes, jet fuel sprayed on the interior, starting fires on multiple floors. Fireproofing was dislodged by the impact and subsequent fires, heating the unprotected steel. Open paths for the fire spread because of an open plan of the impact floors and destruction of the partitions by impact debris. Weakened core columns increased the load on the perimeter columns. Sagging of the south floors led to pull-in forces on the perimeter columns. Bowed south perimeter columns had a diminished capacity to carry loads. The South Tower, or Tower 2, included 7 factors that caused the collapse. There was more direct damage that was done by the plane to the structure than in the North Tower, including more severe damage to the center core columns. Jet fuel sprayed onto the interior, starting fires on multiple floors. Fireproofing was dislodged by the impact and subsequent fires, heating the unprotected steel. Sustained fires on the east side of the building had an ample air supply. Weakened core columns increased the load on the perimeter columns. Sagging of the east floors led to pull-in forces on the east perimeter columns. Bowed east perimeter columns had a diminished capacity to carry loads. Some questions remain. Questions about what happened. How many trusses were destroyed in the initial impact? How many failed in the subsequent fires? How much fireproofing was knocked off by the plane impact? How many center core columns were damaged and destroyed? Which structural elements played primary roles in the collapse and which played secondary roles? Questions for the future. Should lightweight trusses be used in high-rises of the future? Should spray-on fireproofing come under more scrutiny? Should any buildings be exempt from local fire codes and building codes? What role should the fire service play in construction and regulation of a building? In the end, be proactive in securing your safety and the safety of others. Get involved in the construction of a new building. Speak up about the hazards of a building that is presented, and get involved in the code development and adoption process. All firefighters have the responsibility to know the conditions for collapse in different types of buildings, as well as the signs of impending collapse in a given building. They must also communicate these signs to other firefighters. It is imperative that firefighters and fire apparatus be kept out of collapse zones, especially when a fire attack has gone into a defensive mode. In other words, the building has been given up. This means staying far enough away from the structure so that any debris thrown, such as bricks, stones, cornices, etc., during a collapse will not injure firefighters surrounding the building. Class, as always, thank you for your attention. We hope you found that this is a helpful tool to supplement your text. As always, if you have any questions, please make sure you contact your instructor. Again, thank you, and we'll see you in a class in the future.